Now it's turn for optimized fish feed for aquaculture.
So I'll talk about optimized fish feed for aquaculture. I belong to a company called Fermentation Experts. We are no experts in fermentation, I can tell you that. But we are suppliers of fermented feed, soy, rapeseed meal, soy meal, rapeseed meal. We ferment both with and without seaweed. And the primary segments we supply to are sows, piglets, laying hens, and broilers. We are also into food, fermenting different raw materials, plant raw materials for plant-based foods. And our partners who have worked with the fish trials are CT Aqua, working with sea bream and sea bass, NIFO with the marine Atlantic salmon, Luke with freshwater salmon, and the microbiome analysis was done by Nios and Mattis. So our tasks were to develop fermented rapeseed meal, soybean meal, together with seaweed for aquaculture, and compare it with the fish meal currently used in the industry. And this was tested with the salmon, freshwater, and marine, sea bream, and sea bass. And the aim was to optimize the microbiome, to reduce pathogens and increase the nutritional value of the products, and to optimize fish health and performance. So why does one have to develop an alternative product? Currently, commercial fish feed consists, among other components, of fish meal, that's ground fish and fish oil. Producing these feeds is resource intensive. It means that wild fish are caught for feed production, leading to overfishing of small fish. This has implications for the entire food web, since larger fish actually depend on forage fish for food. So, for example, 69% of fish meal and 75% of the fish oil production is actually used to feed farmed fish. Thus, there is an urgent need actually to go away from this and develop plant-based alternatives to fish meal, and that is what we are working with. So why fermentation? Why not use plants as is? Even if you remove the oil, which you do with soybean and canola or rapeseed, the cell walls are still intact. They are not broken. And these cell walls encapsulate nutrients. They could be starch or protein. In our case, we are using protein plant material. And so the protein is unavailable for the endogenous enzymes to utilize. Thank you. So if you look at this drawing here, you have the cell walls. I've colored them red, and the protein is within them. After fermentation, the cell walls break down, and the protein is released, which I have depicted in green. The cell walls break down to give you prebiotic oligomers. And during the fermentation, there's also production of metabolites, such as lactic acid, fatty acids, vitamins, etc. And this is a picture of soybean meal. In red are the cell walls. Green is the protein. You can see cell walls are pretty intact. But after fermentation, the cell walls get broken down, releasing protein or allowing the protein to be utilized by the endogenous enzymes. And all this contributes to good health and performance. This is actually a microscopy picture of rapeseed meal. The red is the cell walls. The protein fluoresces green. So even after removal of the oil, the cell walls are not broken. Thus, the protein is unavailable. And with fermentation, you can break down the cell walls, which is red, making the protein available. And how do we optimize our fermentation? It just depends on the raw material we use. There is a change in the presence of the major compounds depending on the process time. This time could be hours, could be days. We don't do weeks because it just takes too much of resources, and it's not profitable. So the concentration of these bioactive metabolites, it highly depends on the raw material we ferment. Several parameters such as time, temperature, humidity are adjusted, and we have patented this process worldwide. Here is a heat map of metabolites identified by LCMS. The darker the color, the more of the given compound relative to what is found in the other products based on peak areas. So if you look here, this is rapeseed meal. It has quite a few metabolites, for example, fatty acids. But if you see FRSM, that's fermented rapeseed meal, you will have an increase in the metabolites after fermentation. And it goes the same for the free amino acids. Once we have decided our fermentation parameters, we use solid-state fermentation. This is dried, and they were pelleted and given for the fish trials. In the diets, EP199, that's rapeseed meal and seaweed, there was 15% inclusion. And in EP299, that's the soybean meal and seaweed, there was 30% inclusion in the fish diets. So experimental setup. This was done in triplicates. You have a control. The control is with fish meal, and then you have our products with 15 and 30% inclusion of the soybean meal product, and the rapeseed meal product. So during the experiment, fish and the tanks were tended, and this was monitored daily. Environmental parameters such as temperature, oxygen were also recorded. Measurements were taken at the start, intermediate, and final. Measurements of length and weight, the overall condition and health. Gut microbiome and tank outlet water microbiome analysis was also conducted. And in some experiments, immune indicators were also measured. So the data with the freshwater salmon, if you look at, so this is the control, the rapeseed meal, seaweed product, the soybean meal. If you look at the blue arrows, what you can see is that the specific growth rate, the feed conversion ratio in the soybean meal seaweed was significantly better than the control. The rapeseed meal seaweed product was not good enough. And if you calculate the feed cost per gain, what we could also see that there was 12 cents gain for the producer if he used the seaweed soybean meal product here. So fish grow faster, need less feed to put on weight using the soybean meal seaweed product. The data for the seaweed salmon, if you just look at what is done in green, the rapeseed meal seaweed product had significant condition factor, enhanced immunity factors, etc., as well as increased cortisol levels. Whereas EP299, the soybean meal, it had a significantly better specific growth ratio and the feed conversion ratio. Whereas the microbial richness or the evenness was not impacted. For the sea bream and the sea bass, if you look at what is not significantly different from the control, you can see that EP299, the soybean meal product, the specific growth rate was similar to the control. EP299 For sea bass, it was also similar to the control. The immune factors, what is green? In sea bass, it was both were better than the control, and in sea bream, just EP299 was better than the control. But what is important here is that in these experiments, the fish meal was reduced by 50% to produce more sustainable feeds. We get similar production, especially in EP299, the soy product, using half the amount of fish meal. And we see some positive effects in the immune system parameters, which is quite a win. But when we calculated it, our economy guy calculated it, we could not actually see, we could not have a gain. We could not have a profit. So basically, what my company, not me, is looking for is a profit. Every time you replace fish meal and put in the soy, seaweed, or the rapeseed, you need to save. The farmer needs to save. And if we put the combined results, actually there's a lot here, but you can see, if you look at the not significantly different from the control, it's actually a varied picture. You cannot say that, seaweed, soybean is good in this, or the rapeseed meal, seaweed combination is good in certain parameters. And it also goes for the sea bream and the sea bass. We had different results for each of our products. And for the microbiome data, the molecular analysis revealed that the most significant changes in the gut microbiome composition are related to the natural microbiome development in the juvenile to the adult fish over time. For successful application of fish feed supplements, no effect on the fish gut microbiome can be seen as a positive outcome, showing that part of the lesser sustainable traditional fish feed can be supplemented with a more sustainable plant-based feed without affecting gut microbiome and hence its functioning. So, future perspectives. Actually, fish feed producers and farmers, they are interested in the sustainability effect. But whenever we want to approach them with these really good results, they will ask us, what is the saving? And if they get no saving, if they don't have any positive financial effects, they're not going to buy the product, actually. Yeah. And I really want to find out. I've been trying to look at this data since when I got them to find actually what are the reasons for the effects of these different products in these different fish species. We know that soybean meal is more digestible, but yet we do have different results for both rapeseed meal, seaweed, as well as soy. We also need to repeat species. We need to repeat these experiments again. And I was wondering whether we could also combine both, soybean meal seaweed as well as rapeseed seaweed to basically get results, better results. Yeah? Thank you.
Thank you very much for the interesting presentation. And now we have time for questions, if there are some.
So before you start the biological process, you have a certain amount of protein per kilo in your feed. And then you go through the process, and then afterwards, does it affect the amount of protein there is or not?
It doesn't affect the amount of protein, really, but it affects the amount of available amino acids, free amino acids. Yeah, we don't really see an effect on the protein because...
And the amount of... So the free of amino acids should go up because the cell wall are broken, yeah. But we don't know what the total amount is.
It doesn't really go up, actually, no, not really.
But it doesn't go down?
It doesn't go down, no, it doesn't go down either, no. Okay. The total protein, that's soluble.
Yeah, why doesn't it go down? Why is it not also digesting the amino acids?
You mean to say the bacteria taking up the amino acids? Yeah, you're right, but it doesn't do that, actually. Yeah, we kind of break even. Yeah, it's not profitable if it goes down.
No.
Yes.
Fascinating. I have a comment where I am suggesting that you include more positive result than just profit. Because I believe that there will be, based on the huge pollution on non-digested feed under the cultivated fish, and the need for too much antibiotics and other disease protection, I believe that some of your results is indicating that you have higher feed conversion and a stimulated immune system.
Yes. So my suggestion is you count those as positive, because in the future, I believe they have to pay for what they pollute. Yes, thank you. But you know what? You're good friends with my boss, so you talk to him, Lena.
very good.
So thank you, Nympha. So do you know how much of the plant protein which is excreted intact? Have you tried to measure whether or not this protein is converted, or is it some of it is excreted?
Actually, I'd like to refer to my fish scientists who help us with these studies. Eric?
We did not really measure protein in the excrete, but we did measure total nitrogen. There's not really a difference between the three feeds. We have to do a final mass balance, so the total amount of food, etc. But I don't know, there's not really going to be a difference. But I also wanted to make a comment first that although we did find some, growth rates were a bit lower in the, especially the EP199, but the difference is really small. It's about 5%. And you have to also take in mind that these are experimental systems. They are bound by ethics rules for animal testing, so they're really, really clean systems, and fish are really thriving very nicely. And it would be, given the potential effects on immune stimulating, so their defenses, it would be very interesting to go up a scale and to test it in a real fish farm, where conditions are generally a bit harsher, and to see, and then you can see an effect on survival, maybe, and that might even outbalance the negative effect on growth. So I see a really positive future for this these compounds.
Okay, thank you. And now I think that we will have a 10-minute break before having the panel discussion.